Hello, civil engineers. Welcome back to the lecture. So I hope you have prepared the Excel sheet. At least you're done a practice of this. Okay. And here onwards, we'll try to do all these things. Okay. Fine. So once this is done, we have got this value, this and this. Next is I'll write in the bar. I'll teach you later how to prepare the Excel sheet. First, I'll finish this. Come to the bar description. Here I've written C1 column, which is resting on F1 footing. So how many C1 columns are there? There is only one. So that you can even identify from the drawing also. There is only one C1 column, or even in the quantity estimation sheet, if you go, we have written only one. Number of member is one. So that is the reason I've done an input of 1 year. Okay. Now come to the dia of the bar. What is the diameter of the bar? For that, you have to go back to the drawing. And in the drawing, come for the C1 column. So my C1 column is somewhere here. C1 column. Okay, you can see here. And it's written, you're supposed to provide a 16 diameter bar, the longitudinal bar. How many number? 8 number. So 16 dia, you have to provide 8 number. So what I'll do, I'll come to the Excel sheet. Okay, why it is 12 then? This is C1 column, no? Right, C1 column. Okay, C1 column is here. Okay, C1 column is here. And what I've written? 16 dia, 8 bar, isn't it? 16 of 8. Okay, fine. Then I'll make this as 16. Okay. Okay, fine. No problem. It got changed because the moment I keep 16 here, no, everything will change because lap length was depending on this, not an issue. Maybe by mistake I've entered 12 there. Since in the drawing it is 16 diameter, so I've done an input of 16 here. Okay, fine. After that 16, so C1 is here for me. And 16, how many bars are there? 8 bars are there. So we'll make this as 8. So number of bar also I'll do 8. Okay, fine. So the moment I do that, 16 diameter bar, how many bars are there? 8 bars are there. Fine. Next, I want to find the cutting length. How do I find the cutting length? I need to add all the three quantities. So that will be like 14710 plus 330 plus 470. If I do, I'll get the total cutting length. Now you may ask me one question. So this is a 90-degree bend. Why haven't you done that? Again, in the column and all, it doesn't matter that bend whatever you're doing. No, like it's a 90-degree bend. 2D deduction you're supposed to do. Again, for a very same reason, few people follow that, few people don't follow that, but actually it's not required. Okay. If you want, you can do, see, if you want to do here, -2 into D you do. If in a, like I tell, in a company, if they're following, you do that. Okay. But usually it's not required because see, practically that much elongation and all will not happen. That considering that we don't do that. Okay. But if you want, you can do. But here I'm not considering that, and you can follow the same thing. But tomorrow, when you're working, if somebody says that no, that is not the right way, we are following the bend deduction, then you apply the bend deduction. Okay, fine. Because ultimately, like I mentioned, your payment will be done for this only. For example, if I prepare this Excel sheet and in my site the same thing happens, my payment will be done according to 15.51 meter steel only. This much payment will be done to the contractor. Okay, so nowhere we are going wrong. Suppose if you are doing a bend deduction, say 2 into this D. Where is the D? 16. So now cutting length has come to 15478. According to that, 109.96 of steel has gone. Accordingly, we are going to make a payment to the contractor considering this. Okay, fine. Cutting length you understood. This is in mm. Now coming to the cutting length in meters. So obviously, whatever answer I'm getting in mm, if I divide this by 1000, I'm getting in 15.51 meter. Now come to the total cutting length. So whatever this 15.51 has come, it's for one single bar. Okay, and for that C1 column. So total cutting length will be cutting length of one bar. If I multiply it by number of bar, how many bars are there? 8 bars are there. I'll multiply. And how many such C1 columns are there? There is one. So this multiply by this will give me the total cutting length of all 8 rebar of C1 columns, which comes out to be 124.08 meter. Finish. So once this is done, I'm supposed to find the weight of my bar. So since there was 12, I had done the input previously, I have written in 12. So I'll delete it and I'll write it in the 16 column. So this is my 16 column. So 16 diameter plus this answer, I'll multiply unit weight of 16. So the unit weight of 16 is 1.58 and enter. Finish. So I got the answer is 196.05 kg of a steel is required. Only the column longitudinal reinforcement, this much steel is required for me. Okay. So once this is done, next we'll go to the stirrups part, that is a lateral ties. Okay, everything will go together. First we'll find the longitudinal bar, then we'll find the stirrup, I mean the lateral ties. and that will be complete one column. Okay, fine. Now coming to the lateral ties. Now how you have to do the calculation for that? This I'll explain you in one sheet. Okay, so for that I'll go here. I'll take a blank page and I'll explain you that. So yeah, this will take some time. So okay, now let us consider I have a column, I have a lateral ties. Okay, this is a lateral ties. Okay, and the size of that is given. This is a lateral ties, what we usually put, and here the column size is given. The column size was let me check what was the column size. Okay, you cannot see the column size also here. I'll come back to here. So the column size was C1 column, no? C1 column, it was 200 by 350. Okay, so it is 200 by 350. I'll write it. So the column size was 200 by 350. So 200 by 350. Okay. One more thing is that you just need to check the drawing, which is 200 and which is 350. So this is C1 column. See, this is that. So your column is like this. Okay. This means this portion is 350, but I have drawn it wrong. See, this portion is 350 and this portion is 200. You will ask me, sir, how did you understand? Very simple. You see the size. This is 300. This looks bigger compared to this. That means your breadth is 200 and your depth, this is called as 300, 350 mm. Okay. Then I'll change my drawing then. So what I'll do is I'll go here only. I'll write somewhere. I'll do somewhere here. Okay. So I'll do somewhere here. Yeah. So it is something like this. So it is something like this. This is a lateral test what I'm supposed to put. Okay. So it will take some time of yours to understand the concept, but it is very simple. And what is a column size? Column size is 200 by 350 mm, isn't it? 200 by 350 mm. So how do you find the cutting length? So I want to find this cutting length. See, this is column actually. This is your column. This is your column dimension. Okay. But inside that, it will be a lateral ties. So this cutting length we are supposed to find. Remember, in the column, your clear cover will be 40 mm. So if I want to find this length, if I want to find this inner length from here to here, and I want to find this length from here to here. Okay. How will I find that? I'll explain you how it has to be found. So go to the Excel sheet. You'll see what I've done here. Okay. So where is my, so what happened? Got deleted. Okay, fine. We'll start from here. Hmm? So how do you find the cutting length of this? First, I'll find this cutting length. I'll find this cutting length. Okay. This is 350 for me. If you want, I'll write that also. Let me drag it out. Okay, this is column size. And this is 350. This is 350. And this is 200. Okay, fine. So first we'll find the 350 side. This length I'll find. So it's very simple. 350 overall length minus from the left side I'll take 40 mm cover. This gap whatever you see, no, this is 40 mm from the left side, minus from here this is 40 mm, this is 40 mm cover, minus. Okay, so when I do this I'll reach up to here. I'll reach to which point? From this outer to this outer. But usually when you find this, so we have to take from center to center. That means actually your bar will be here. Your bar, you will be having a bar here. Okay, we'll be having rebar here like this. This bars will be there. Only then it will look like column, no? So usually what we do, we go from center to center. That is center of this rebar to center of this rebar. You're getting my point? Now I've reached to the outer one. I've reached to this point and I've reached to this point. Okay. So what I'll do, I'll come to the center to center. That is, I have a, yeah, to make it better, no, I've done this particular thing. Now I'll explain you what I actually wanted to tell. So I want to find from the center of this stirrup to the center of this stirrup. Okay. Getting my point. So what I did, 350 is outer to outer minus 40 mm cover I have taken out from the right side, 40 mm cover from the left side. Okay, now where did I reach? I reached to the outer of the stirrup outer to outer I reach. But few people, what they do, few people stop there only. So they say this itself is a length. But if you refer Indian Standard Code Book, that is IS 2502, this is a code book. So if you refer to the code book, and what we usually practice is we go up to the center. So always whenever if you do to the center, you'll get a better answer, you'll get a correct answer. Again, it is completely depending on the type of the project and type of the company where you work for. But whatever I'm telling, most of the people, we follow this only. We go from center to center. Okay. So that means what is the diameter of this stirrup? It is usually 8 mm. Again, in the drawing, it will be mentioned. So I'll take you to the drawing. Yeah. So it is mentioned here that you are supposed to use a 8 diameter bar. See here, C1 column. So it's a 8 at 200. So 8 is a 8 mm. Okay, see, there's some problem. So everything got deleted. Now I need to do it again. So I hope you have understood that. But anyhow, I can't bring that back. I need to redraw it. Give me a second. Yeah, I redrawn it. Okay, fine. So what we did, outer to outer, that is 350 minus left side 40 mm cover minus right side cover. So what where we did, we reached here. That is the outer of this stirrup to outer of this stirrup. But usually, like I mentioned, we need to take from center to center where we get accurate answers, and that is a right way of doing the bar bending schedule. So if I want to come to the center of this to the center of this, if I this stirrup diameter is 8 mm. If I take half of that, it will be 4 mm. So from here I'll add 4 mm, and from here I'll add 4 mm. So okay, I mean I'll deduct 4 mm from both the side. One way of understanding. Other way of understanding is you just deduct the diameter of the stirrup. Instead of minus 4 is minus 8. Instead of doing that, whatever is the diameter of your stirrup, you deduct that. Directly I'll do that. So directly I can write minus 8 because I've written the diameter of the stirrup is 8 mm minus 8. Now you tell me what answer you got. You do it manually. So it is 350 minus 40 minus 40 minus 8. So I'm getting 262 mm. Fine. So this 262 mm is this length. Which length? This length. 262 mm is the length from here to here. From this center to this center. Okay. So this will be the cutting length of this side. Similarly, this also will be 262. But now we want to find from this center to this center. That means we want to find this also now. I'll give a different color. I want to find this center. Okay, I'll keep black only. Yeah. I want to find this center now. And from there to this center. Again, same procedure will apply, provided this time your direction, the way you go is different, will be different. Okay, from this center to this center I want. What you will do in that case, again, same thing. See, I know this length. Which one? This length. How much it is? How much it is? 200 mm, because that is what there in the drawing. So it is 200 mm, no? Where it is? Yeah, 200 and 350. C1 is 200. Okay, you're getting my point, no? So it will be 200. So if you want, I'll write here. This is 200, outer to outer. Okay, 200. This is 200. From where? This portion. This outer to outer is 200. In that, 40 mm cover is gone. So this is a 40 mm cover. 40 I'll write here. And here 40 mm cover is gone. So what is left out? Write it here. So 200 minus 40 from the downside minus 40 from the top side. Okay. Now where we reached? Outer to outer we reached. Minus diameter of stirrup. What is the diameter of a stirrup? It is 8 mm. So now if you do this, I'll come to center, and whatever answer I get, this will be this answer. Got it? Agree with me? Try to do this manual calculation. So again, 200 minus 40 minus 40 minus 8. So I'm getting 112. How much I'm getting? 112 mm. That's so this will be my cutting length. So now I want to find the cutting length. That means if I add this 262, and if I add this 262 from here, and if I add this 112, and if I add this 112, will I not get the complete length of this particular stirrup? I'm going to get. But along with this, there's one more catch. The catch is usually your stirrup will be something like this, isn't it? It will have a hook in this way. This hook length also we are supposed to add. I'll teach you that later how to add. But right now, whatever we have done is correct. Okay. Now, this much you understood. I'll delete this and I'll take you to the Excel sheet. So now come to the Excel sheet. Yeah, see here what we have done. Okay. Now, in the Excel sheet, I've written here ties. We call it as lateral ties. How many numbers? Same. Whatever number of column will come, same will be a lateral ties. Okay. Only the thing is the diameter of your lateral ties is usually 8 mm. That you can find from the drawing. So it was written 8 mm for C1 column. My lateral ties. This is main stirrup, which we took 16 diameter 8 bar. For stirrup, it is mentioned 8 diameter at 200 center to center spacing. So I'll come back to the Excel sheet. So I'll input here 8 and I'll input the spacing as 200. This much you're supposed to do. Now this length, how did I find? Very simple. What I did, if you want, I'll do again here. What I did plus what I did. First, I took the size of the this thing, which is that column. So I took 350 minus left side 40 mm cover minus right side 40 mm cover minus diameter of the stirrup. So diameter of the stirrup was 8. I clicked on it. I hit the enter button. Did I get 262? I got. Next, what I did, I brought it to the center. Finish. I brought it to the center. Got it? In this way, you're supposed to do that. So I'll delete it. I explained to you here. Whatever I did, I just interlink that here. Nothing. What you're supposed to do, whatever you got, come here, keep your mouse here. You know all those things now. But anyhow, later I'll teach you to prepare Excel sheet and say plus 262, finish. You, okay, you got that answer. Done. Now come to this side. This side also you know how you did this. I'll do it here. For this side, what I did, yeah, this side what I did plus what is the this thing length was there, what is the breadth of that? So breadth was 200 minus 40 mm from the left side, 40 mm from the right side, top 40 minus 40, and then one diameter minus I told diameter of the stirrup. I'll get 112. Manually also I got the same thing. Agree with me? See, 112 I got and 262 I got. Same thing in the Excel sheet I got. Okay, this much is understood. Great. So this thing, next if I add everything, next if I add this 262 plus 112 plus 262 plus 112, I'll get the total cutting length. But I told you, we have something called as hook. This hook also we need to add. Okay. So how do you add this hook? That I'll tell you. Finish. Up to here it is clear. You understood the spacing. Now we'll find the number of bar. What we'll find? We'll find the number of bar. Means, for example, practically. Okay. See, you can see a lot of stirrup given here. A lot of stirrup like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How many stirrups are there? So many stirrups are there. How you'll find how many stirrup is required? So for that, what you do? Very simple. For that, you have to take the total height. For that, what you're supposed to do? Okay. Okay. We'll start from here. Okay. Else I can take this in the next lecture also if you find it confusing. Anyhow, I'll explain it here. So how do you find the number of bar? So always remember, whenever you put this rebar, this stirrup will start from the bottom itself. Okay. So what I have done, from here it will start. I explain you from here. Okay. This stirrup you are going to start from here. Okay. So it will be from footing. Yeah, from footing. From here itself only it will start. From here itself only your stirrups are going to start. It will go till the top of that. Okay. So for that, what we have done, we know this height. Yeah. Okay. I'll check what I've done. See here and C13 is here. Where is C13? Okay. C13. Minus D13. Okay. C13 is here. No? Okay. Fine. I'll explain how it has to be done. I'll start from here. Plus, I'll do open bracket. Okay. What was the depth of the excavation? It was 2500. 2500 minus what I'll do, one cover I'll take out because directly this lateral ties will not start from the bottom. One cover you'll leave. So minus 50 I did. Minus on the footing, we had provided a shorter diameter bar and longer diameter bar. That also I need to deduct. So that means minus, I'll do this one. This 10 dia minus this 10 dia I'll do. So if I do this, no, everything is finished. Okay. So I'll close the bracket. I'll hit this answer. So what I planned is I'll explain you here. So there's one drawing which I need. Let me find that drawing. Yeah, you understood now what I did. See, what I did is this is actually a footing for me. Okay. Let us say my footing height is up to here. Okay. This is from here is my ground level. From here, my excavation is going to start. Okay, so this was actually 2.5 meter if you remember the drawing. So 2.5 minus, you'll see this lateral ties what we have, no, this is your lateral ties. It is not going to start exactly from the bottom, it will start from here. This is the first lateral ties we are going to find. Okay, so that is why what we did, we took overall depth, that is 2.5 meter, minus your bottom for the footing, you'll give a 50 mm cover, minus you can see this shorter span 1 diameter and longer span diameter. If I do, I'll get the height of this lateral ties, that is the first lateral ties height from here. Getting my point? That is why I taught you this is how it has to be done. So what I did, I'll go back here, I'll explain you once again. So what I did, 2500 is a depth, what was there in the drawing, minus the bottom cover 50 mm, minus the lateral ties in the shorter span, I mean minus the footing shorter span bar and the longer span bar. Got it? Fine. After this, very simple. Now by doing this, where did we reach? By doing this, where did we reach? We reached up to the natural ground level. That is till the bottom of the plinth beam. After that, you should add the height of the plinth beam plus first floor, second floor, third floor. If you add all the height, you'll get the total height. Very simple. So what I'll do, plus 350, that is the depth of your plinth beam, plus 3300 ground floor height to first floor to second floor, and from there to the last one, it is 3300. Okay, 3300 plus 3300. Enter. How much you got? I got 12,680. Okay, and how much did I get here? Where was that? Yeah, it is here. Later I'll divide that. Okay, same thing I did. See, plus 350 plus 350 plus 3300 plus 3300 plus 3300. Last one thing we didn't do here. What was that? That is in this, whatever height I took, that I took till the top. But there's small 40 mm cover you need to leave, no? Because your stirrup or the lateral ties will not go to the full top. From here, you'll give a gap of 40 mm and it will stop only up to here. So that is why what we'll do minus 40 mm. Okay, minus 40 mm. So this is the overall spacing we got, overall height we got. If I want to find the spacing, this height, if I divide by the center to center spacing, how much it is center to center spacing? It is 200. I'll get the number of bar. Obviously, I'll get. So what I'll do, I'll take this value now. So I'll write here plus open bracket this value. Okay, I'll divide it by which one? 200, and I'll close the bracket and I'll say plus 1. Okay, because you're finding the lateral test. You know that whenever you're finding the number of bar, you need to add 1. I'll hit enter. How much I got? 64.2 I got. Here I got 64 because I wrote this thing, comma and 0 I given to make it round figure. I can do that also. I've done a roundup of that. Okay, so if you do that, you'll get the right answer. So here I got 64, here I got 64.2. But anyhow, you follow this. I mean, I explained you in 2 steps. Now you understood the concept. I'll put it in one single step and explain you. How did I get this 64? Come here. First I've done round up, 2500 overall depth minus your bottom cover 50 minus shorter span diabar minus longer span diabar. Okay, fine. Plus 350 is the height of the plinth beam, plus 3300 ground floor to first floor to second floor, and then third floor, that is your roof floor. Minus 40 is for the cover we have to do, minus 40. Whatever answer you get, this should be divided by the spacing. What is the spacing? We had 200 spacing, and then comma and 0 to make it round figure. Otherwise, you'll get like 64.1, 63.1. To make it a round figure, I have given dash and 0. I have closed the bracket. Finish. I got the answer. So totally, I require 64 lateral ties if I want to do the complete column of this height. If I want to put the lateral ties, how many lateral ties is required? 64 number is required. Simple. Good. Now once I found this, next what I'm supposed to find? I'm supposed to find the cutting length. I'm supposed to find this cutting length. So in cutting length, you need to add 262 plus 112 plus 262 plus 112. But how do you measure this? This ring, this hook, whatever you have, no, this hook. How do you find the hook of that? Okay. So that hook I'll teach you in the next lecture how it has to be done. I'll stop my lecture here. Otherwise, it will be a very long lecture. So up to here, you practice whatever I explained you. Okay. And in the next lecture, I'll teach you how to calculate this hook. And later we'll finish this particular thing. So once we understand this, after that, I'll teach you another lateral test, how it has to be done. So if you do this, no, one complete column I will explain you. Okay. After that, I'll explain you once again in a very detailed way. I mean, overall, I'll explain you. Right now, I'm breaking down my lecture so that we'll understand it part by part. So it's very simple. To find the lateral ties, you've understood how it has to be done. This hook part, I'll explain in the next lecture how it is to be done. Okay. So practice up to here. Try to do it manually, learn it, and in next lecture, we'll finish this. So we'll see you back in the next lecture. Thank you.